Okay, Bismillahirrahmanirrahim. Assalamu alaikum, everyone. Welcome to seventh day of our this journey. A quick study of Saudi Aramco CSM with Abu Abbas, Part 2, Chapter 2, Scaffolding. Today we will I lost my pointer, I think. Anyhow, let us proceed. Or just excuse me if I a moment. Okay. So we will talk about the continuity. We left, I think, yesterday here, the continuity of D. Anyone? 2.5.8. Yes, Mrs. Laudin.
Yes, sir.
Okay, so ties shall be installed adjacent to transverse vertical braces. Figure 236. Transverse and vertical. Vertical, the one which is in upright. Okay. And the one which is on the horizontal face plan, we call them as uh, plain brace or horizontal brace. So it says ties should be or shall be closer to the transverse brace. For example, as here you can see, यहाँ आप देख रहे हैं टाई है कि हमारी ये हमारी टाई ट्यूब आ गई और it is closer to the vertical braces and those they are transverse braces. मतलब width साइड पे हमारे पास जो braces लगी हुई हैं उनके क्लोजर हमने इसको लगा दिया है. The lowest level of tie shall be installed at the lift location closer to the height of 4 times of the minimum होगा. Is missing minimum base dimension 4:1. Okay. So 4:1, as we know, minimum width multiply by 4. Let us say it is 1.5. So how much it will be? 6 meter. So from the base till the 6 meter, the first tie will come, where the 4 into minimum width dimension is achieved. जहाँ पे minimum width dimension into 4 होगा, जहाँ पे वो अचीव हो रहा होगा उस हाइट पे हम पहली टाई लगाएंगे.
यानी सर फिर एक मतलब फॉर एग्जांपल अगर नीचे अगर हमारा जो विड्थ है फॉर एग्जांपल 2 मीटर होगा तो हमें 8 पे लगता है.
2 मीटर होगा तो 4 दूने 8 मीटर में हमारी जो पहली टाई हाइट पे लग जाएगी. 2 into 4 8. सो एट 8 मीटर ऑफ एलिवेशन हमारी जो फर्स्ट टाई आएगी.
ओके.
In vertical it will come, but in horizontal at both ends we put tie, and then we will go with another class that where we have to put the next one. The upper level of the tie shall be installed as close as feasible to the top of the scaffold. Next, the one which will be the next one, again we will have a particular distance, we can't go beyond that. एक मखसूस हद से ज्यादा गैप हम नहीं देंगे, लेकिन जितना क्लोज हाइट से होगा उसको हम लगाएंगे क्लोज हाइट से रख के. टाई शैल बी स्पेस्ड vertically every 8 meter 26 feet. 4 lifts are less. Why 4 lifts? Because we know that normal lift height is 2 meter. So 2 into 4, again we have 8 meters. तो अगर हमारी ये बेस टाई है, इससे अगर हमें ऊपर जाना है, we have to go further or beyond that initial lift. If we are talking about a long, tall scaffold, so again every eighth vertical meter, or if we go with the lift, for every fourth lift, okay, we have to put on another set of ties from one corner to other, from one end to other end. Okay. Again, the set least is both sides. Least is both sides. ठीक है जी। तो जैसे हम पहली टाई जो हमारी 4 इंटू मिनिमम विथ डायमेंशन मैक्सिमम, इससे कम पे हम लगा सकते हैं लेकिन इससे ऊपर पे नहीं लगाएंगे। उसके बाद वर्टिकल में हमें हर 8 मीटर के बाद या 4 लिफ्ट, अगर हमारी थोड़ी बहुत लिफ्ट छोटी है तो बड़ी होगी तो नहीं। इसमें हमेशा याद रखिएगा, फ्रॉम सेफ्टी परस्पेक्टिव विच एवर कम्स फर्स्ट, जो भी हमारे पास वैल्यू पहले आ रही हो हम उसके साथ जाते हैं। I think no one is at the time in waiting room, but still I appreciate. Okay. Further, ties shall be installed at both ends of the scaffold and at horizontal intervals not to exceed 9 meter 30 feet, measured from one end towards the other end. So if we are going in this direction, this is our first tie, and we will have another tie at the end. In between, we will go every 9 meter. For example, let us say it's 2 plus, and almost here, we can bring it closer. Now, in this situation, we have reasonably less distance. It's not 9 meter if we go beyond this. So it's better we come lesser than 9 and we put it near to the uh, node point. Actually, we called it the vertical and horizontal member where they are coming together. तो हमें अब 9 मीटर पे लगानी है। इस लिफ्ट के ऑलमोस्ट अगर आध में आ रही है, अगर हम इसे 2 मीटर कंसिडर करते हैं तो हम इसे पहले लगा लेंगे, क्योंकि आगे हमारे पास 9 मीटर से जगह कम है। और कम ना भी हो तो एक आध टाई एक्स्ट्रा होगी, हम इस तरह की एडजस्टमेंट कर लेते हैं ताकि ये वर्टिकल मेंबर और हॉरिजॉन्टल मेंबर जहाँ पे आपस में करीब आ रहे हैं, ये नोड पॉइंट है, इसके करीब टाई लग जाए। जैसे कि हमने पहले ब्रेसेस के लिए देखा कि टाई ट्यूब जो है वो ब्रेस के करीब आ जाएगी, हॉरिजॉन्ट वर्टिकल और ट्रांसवर्स ब्रेस के करीब। मतलब अगर हम वर्टिकल और लॉन्गिट्यूडनल कहेंगे तो फिर ये हमारा टाई पॉइंट, मतलब इसके करीब। लेकिन डेफिनेटली जो फिगर हमारा है, दोज फिगर्स वी हैव टू अचीव। तो ये जॉइंट्स हमारे वर्टिकल टाई के करीब आते हैं, ये तो दोनों के करीब आ गया। ठीक है जी, कोई सवाल?
नमस्कार।
सर फिर से एक दफा एक्सप्लेन कर सकते हैं?
जी।
हाँ, फिर से एक दफा एक्सप्लेन कर लीजिए सर।
ओके,
सॉरी।
तो समराइज करते हैं इसको जी, कि जब हम स्काफोल्ड बनाते हैं तो उसकी मिनिमम विड्थ डायमेंशन, जो साइड छोटी होगी, इंटू 4, वो हाइट जब हमें अचीव होगी तो हम पहला सेट ऑफ टाइज, पहली टाई का लेवल वो आ जाएगा, तो पहला सेट ऑफ टाइज लगाएंगे जो हमारा
ओके।
एक कार्नर और दूसरे कार्नर पे है। उसके बाद सेकंड हमारे पास ये आ जाता है कि वर्टिकल के लिए हर 8 मीटर के बाद हमें फिर टाई लगानी है। हर 8 मीटर के बाद हमें फिर टाई लगानी है, और लास्ट टाई जो होगी वो एज मच पॉसिबल हम वर्किंग प्लेटफॉर्म के करीब लगाएंगे। लेकिन अगेन, अगर 8 मीटर से ज्यादा जा रहे हैं तो हम एक और टाई लगा लेंगे, 8 मीटर को क्रॉस नहीं करेंगे। हॉरिजॉन्टल डिस्टेंस में हमारे पास टाई का इंटरवल जो है वो 30 फुट या 9 मीटर है। तो हर 9 मीटर पे हम दोबारा टाई लगाएंगे। जैसे अगर हम इसे 2 मीटर बैक कंसिडर करें तो 9 मीटर यहाँ सेंटर में आता है, तो ऐसी सिचुएशन में बेहतर है कि हम जहाँ पे हॉरिजॉन्टल और वर्टिकल मेंबर, जहाँ पे अपना पोस्ट और लेजर और ट्रांसम जो है वो करीब आ रहे हैं, इस जगह को प्रेफर रखते हैं टाइस के लिए, क्योंकि यहाँ पे तो हमारे पास आगे सिनारियो में जगह भी कम है, और अगर हो भी तो एक आध टाई एक्स्ट्रा हो जाएगी। टाई के लिए बेहतर ये होता है कि वो वर्टिकल हॉरिजॉन्टल मेंबर्स के नोड नोड पॉइंट, अब ऐसे बोलते हैं, नोड पॉइंट के करीब रहे।
ओके।
ठीक हो गया जी।
ये ठीक है, थैंक यू।
वी विल मूव फर्दर। तो आगे हमारे पास क्या है जी? When used, revel tube shall be securely wedged using revel pin, for the figure in the 2.37, between opposing surfaces on the building or structure and coupled to tie tube. Almost, okay. Almost, it's like a screw jack, but definitely it's a revel pin, a component of revel tie. So revel tube, the tie tube will be here, and we tighten through, we screw it or we jack it out to which it or fix it between the opposing sides. And then from the tube, as we discussed earlier, the tie tube, the tube which will go from the tie towards the scaffold, we refer it as tie tube. तो जो टाई से लग के, चाहे रिवल टाई है, बॉक्स टाई है, कुछ भी है, उस टाई से इंगेज होकर, कनेक्ट होकर स्काफोल्ड की तरफ जाती है, उसे हम कह रहे होते हैं टाई ट्यूब। तो ये टाई ट्यूब will be attached with two members of scaffold, either horizontal or vertical. To ensure the security of revel tube, it is necessary to frequently check for tightness. Definitely jack है, screw है, it can become loose. So during inspection, एक तो है when we will do inspection, but beyond that, in normal routine, time to time, we should check these ties because they are critical components. We cannot wait for 14 days to check a tie. Ties to revel tube shall not exceed 50% of the total number of ties used on the scaffold and shall be evenly distributed over the area of the face of the scaffold. तो दो चीजें हमारे पास आ गई जी। रेवल टाई shall not exceed for 50% of the total number of ties. Let us say we have 16 ties. So revel tie cannot be more than 8. Okay? More than 8 numbers. That will be 50% of total ties. And then the second thing is shall be evenly distributed over the area of the face of the scaffold. Like अगर हम previous पिक्चर पे एक दफा जाएं, तो अगर हमारे पास रिवल टाई है, इफ वी हैव रिवल टाई, वी कैन नॉट डू लाइक दैट कि हम रिवल टाई, इफ वी पुट वन हेयर, द सेकंड हेयर मींस इन रिक्वायर्ड डिस्टेंस, थर्ड हेयर, फोर्थ हेयर, फिफ्थ हेयर, सिक्स्थ हेयर, seventh and eighth, so we achieve 50%. Now other ties, no, they shall be distributed. If we have rival tie, we have to have another tie here, so we will prefer to have something else, yeah, on a distance. So a mix scenario should be, it will be used with other ties, but with a mixing. Okay, we cannot go all in one area together, and with the rival tie and then go to another one. ठीक है जी। तो इसके लिए रेवल टाई के लिए ये कि 50% से ज्यादा नहीं होगी, और इस 50% के लिए ये भी देखना है कि एक ही जगह नहीं पूरा कर देना, मतलब ऊपर नीचे आगे पीछे हमने 4-6 टाइल्स लगानी है तो हमने यही लगा दी, और बाकी जो बची तो आगे दूसरी लगा दी, नहीं, इवनली डिस्ट्रीब्यूटेड हो, क्योंकि लोड बेयरिंग और द स्ट्रेस हैंडलिंग, आई कैन से, of rival is not that much supportive as the others. It will handle against the load, but again, as we are saying, we have to check for the looseness, loose ho sakti hai, any other impact. Okay. And definitely, it's in between. A force is pulling it out, while a box tie or through tie is more stronger than that. So a mixture of one another. Completely एक तरह की टाई हम रिवल दूसरी अगर है डजेंट मैटर, तो रिवल सारे एक क्लस्टर में नहीं लगाएंगे. Stability, okay. F point, when used, outrigger frames. When used, okay, what we are going to use, outrigger frames, shall extend the base dimension to more than 1.4, 1/4 of the scaffold height, or 1:4 ratio of scaffold height. Secondly, the stability of a scaffold may be achieved by the use of Rakers 2.3, and only if it is impractical to provide ties or outrigger frame. Okay. Now, Raker, which picture there was? No, Raker is here. What we called it, outrigger frame. As we have previously a scaffold picture, that we have a scaffold and we made a section here, outrigger frame. Okay. So why we made it? Because we want this dimension, the least dimension, to be more than 1:4 ratio 1. Okay. So therefore we made this extension. Now if the extension, this outrigger or any other type of tie, if it is not possible, then we will use the Raker. Okay. Raker is what? It's a literal support. ये साइड से सपोर्ट आई हुई है, ठीक है जी, ये लिटरल सपोर्ट है, ये हम यूज कर सकते हैं when we cannot use other means. So criteria, each Raker shall be a single piece of scaffold tubing not more than 6.4 meter, 21 feet in length. 6 meter normally we called it, but 21 feet exactly, or 6.4 meter the tube is. So roughly we called it 6 meter tube. One single tube can be in Raker. We cannot joint or splice the tubes in a Raker. Once again, this is what we are referring to Raker. This diagonal or literal support, we'll say. One criteria, we can have less than that, 4, 3, whatever is fulfilling our requirement, but maximum one length, no joint. Whatever the size will be in single length. Shall not be joined, spliced together, okay. The Raker angle above horizontal shall not be greater than 75 degree, 4:1 ratio, or less than 65 degree. So if we calculate this degree, let us say that's our horizontal member, we can do it from the ground as well. So if we make the degree, it is supposed to be 65 to 75 with 10 degree margin. We can install it. Not less than 65 and not more than 75. The literacy or the literal or the angle, you can say. Only one additional lift may be installed on the scaffold above the Raker tie-in point. So if the Raker is here, okay, this is the last thing we can use. Or even it is here, that's the last thing we can use. Means if it is here, that is the next lift. So if it is above, like here, it is above the lift, then the next lift can be. If it is here, somewhere here, then this is the last lift. Above the Raker, only one lift. This is our lift. Lift 1, lift 2, lift 3. We know that this is what we refer to base lift or kick lift. So it's not counted in calculate or in numbering. The lift will be once it reached to here. Starting from here to here, then to here, then to here. Okay. तो किक लिफ्ट से ऊपर जब जाएंगे तो पहली लिफ्ट आएगी, फिर दूसरी, फिर तीसरी। तो जहाँ रेकर जाके अटैच होगा, टाई इन होगा, वहां से ऊपर एक लिफ्ट हो सकती है। ये रेकर अगर इस बैरियर से नीचे हमें दिखाया होता तो फिर ये आखिरी होना था। ये तो यहाँ पे भी अटैच है तो ठीक है, ऊपर एक लिफ्ट हो सकती है। The top of the raker shall be coupled to the scaffold no higher than the third lift. Okay. Again, another criteria, it says that this is first lift, this is second lift, this is third lift. Okay. So the raker we cannot put beyond the third lift. If we are using single tube, hardly we will reach to two second lift. But in case the lift is smaller, lift is not what we can say of 2 meters. In that case, maybe we have more lifts, maybe any special scaffold. So we will not go beyond the third lift. In that case, this is first, second, and third. Shall be coupled to the scaffold no higher than the third lift. So it will be below the third lift. Like here it is first lift, second lift, third lift. It is below the third lift. Moving further, the bottom of the raker shall be coupled to a firmly anchored ground stake. Okay. The ground should be firm definitely to have the lateral load or load imposed on that. Bottom of the raker shall be coupled to a firmly anchored. Okay, ground have to be firm and the anchor have to be firm. Anchored, what it says, ground stake or otherwise well anchored against movement in all direction, including uplift. So ground stake अगर हमें कोई मिलता है, okay, so like here something we have as sole board and base plate. Base plate is fixed to the sole board and raker is there. In this case, the base plate will be again it can be used inclined. This is alternate. We can go with this. If it is hard ground, we can have the what we call them, the royal plug, the bolting. That one we can do. In this case, okay, it is acceptable. But what against the uplift? How we will protect it against the uplift? So in this case, if we put it here, a butting tube or in any bow structure, or we make it column tie if we can. But the question is, if we can make a column tie, we make a column tie, then why we are using raker? But anyhow, if we can protect, then simple thing like this will be acceptable. Otherwise, the pipe should be attached to anything which will protect against uplift. ठीक है, ये पॉइंट समझे आपके। इसमें अपलिफ्ट को भी हमने देखना है। अगर स्काफोल्ड बैक जाएगी तो रेकर ठीक है संभालेगा, ग्राउंड कंपैक्टेड है तो अगेन उसको बैठने नहीं देगा। लेकिन एट द सेम टाइम अगर अपोजिंग डायरेक्शन में फोर्स लगती है तो फिर उसका कॉमन हमारे पास सोल्यूशन ये हो सकता है, अगर हमारे पास उस तरह का एंकर पॉइंट ना हो तो हम यहाँ पे इसको एक बॉक्स टाई दे सकते हैं। लेकिन बात फिर वही आ जाती है, बॉक्स टाई देंगे तो रेकर का फिर क्या जरूरत है। और अगर बॉक्स टाई नहीं है तो फिर हम बुटिंग ट्यूब कुछ इस तरह स्ट्रक्चर के साथ छोटा पीस ट्यूब का लगा सकते हैं, कि जो अगर फर्दर मूवमेंट हो उसका फोल्ड की तो वो स्ट्रक्चर के अगेंस्ट उसको सहारा दे। जो भी 2, 4, 6 इंच का गैप उसकी मूवमेंट हो सकती है वो बुट ट्यूब से या छोटे पीस ऑफ ट्यूब से स्वे टाई ये वो हम लगा सकते हैं। स्विंग साइड होती है, लेटरल होती है, उसी चीज को मतलब रखते हुए फ्रंट पे अगेंस्ट द वाल हम उसको लगा सकते हैं। ठीक हो जी, कोई सवाल इस पे?
नहीं सर, नहीं,
कॉम्प्लिकेटेड है नहीं है, बस
क्लियर है
तीन
सर।
चार तीन चार चीजें याद रखने की है। ट्यूब सिंगल होगी, ओनली सिंगल ट्यूब, 65 to 75 डिग्री, then no more than third lift. Okay, or the anchor or the ground support should, the anchor on the ground should support against the uplift as well. याद रखने से मुराद definitely we are not talking about exam. Anyone can go for exam, but basic purpose is understanding. So we can utilize it anywhere, either a scaffold, uh, craftsman, and supervisor receiver qualification, or safety, or as a general knowledge. The worst thing for safety is that every job is your job. You cannot say I'm safety, oh, I don't have concern or no need or not related to. Everything is related to safety, especially like our jobs of construction. If you are industrial, it can be a specific, but definitely whatever will be the scope or related things. Okay, ji. Further, in addition to the bottom and midpoint of every raker shall always be tied back to the scaffold by horizontal tube coupled to the raker and to at least two scaffold post standards. Okay. In addition to bottom and midpoint. So this is what we refer to the bottom kick lift, bottom and midpoint of the raker. Almost we have this center. Again, this is attached, tied back to scaffold. Midpoint of every raker shall always be tied back to scaffold horizontal tube couple, horizontal tube. Okay, this is a thing to remember, that horizontal means the ledger we are going to transom. It can be, but because they are at the face direction facade, so they are going to be with the runner or transom. Okay, coupled to the raker and to at least two scaffold posts. Okay. Shall be tied back to scaffold by horizontal tubes, coupled to the raker and to at least two scaffold post standards. And at one raker at the same time, bottom and midpoint of the every raker shall always be tied back to the scaffold by horizontal tube, coupled to the raker. Okay. Yes. So let me clarify it here. Top raker is itself going to be attached. For the bottom, we will put a horizontal tube. Okay, make it sure you understand it. What I am going to tell you now. A horizontal tube from the raker will go back and will be attached with two standards. Okay, I just miscalculated or misunderstood that. From the raker, our tube to the post, two standards. Okay, so we are putting it on the standard base. Horizontal tube from the raker to two standards. Clear?
Yes, sir.
Clear, sir.
Okay, thank you. Make sure if you have any doubt to clarify it, because the purpose is not just an explanation or translation. So must understand the things. Okay, next we have tie or outrigger shall be used to prevent tipping of base supported scaffold in all circumstances where an eccentric load such as cantilever work platform is applied or is transmitted to the scaffold. So cantilever we know, one which is extended. Now in this case, this platform have to have its own load capacity, but at the same time when it will be loaded, there will be a uplift load at the back, the support side of the platform. So this is an extra load, a critical load again on the scaffold. So whatever we use for stability, remember ties, outriggers, rakers, they are for stability. Okay, and brasses we use for rigidity, should not have movement. Okay, so they must support any type of tie or Raker or Outrigger. They must support the scaffold against any type of load which will be any critical load which will be implemented. For the platform load and this that we know it will go straight down. But these are other loads, those can tipple or uh, lean a scaffold here, there. Okay. The eccentric effects of an access ladder. And now one effect is that load is implemented. Then it is in a direction. Okay. It's in a direction. Let me bring the camera near to. Okay. Because human nature, when I look at that side where the pictures are supposed to be. So, centric effect of the scaffold, effect of an the centric effect of an access ladder, like the ladder we use, an external specifically, that is external to the work platform and outside of the scaffold structure shall be properly addressed to ensure stability of the scaffold. For the towers, internal ladder is preferred because when the ladder is internal, the load is, we can say, remains inside the posts. Okay, it do not become eccentric or a critical type. And when the ladder is outside, definitely as the person will go, there will be a factor of load, what is referred here eccentric load, okay, as an additional at the time of movement. So when outside ladder is installed, we have to consider that load as well. Okay. So normally in the longer direction, in the not the minimum, the maximum, the bigger direction, either transverse or longitudinal. Mostly the longitudinal is more. So we put the ladder in that direction. So we have a little bit more stability. Connection of the scaffold lift shall be made secure and fully tightened before assembly of the next lift. Again, whatever the connections are, the proper torquing of the or tightening of the bolts. Whatever else can be, lift shall be made secure and fully tightened. Maybe we have a tie point there, maybe Raker or Outrigger. So we'll make sure those are complete, tight, secured. Then we will go further. When a scaffold is being dismantled, the component above each tie shall be dismantled or removed before the tie is removed. Stability shall be maintained while the scaffold is being dismantled. So when we are bringing scaffold down from top to bottom, definitely. So in this case, whatever before removing tie, we will dismantle the above section. Once above section is dismantled, then we will come to the tie and we will remove the tie. Again, the complete length of the tie array. Length mean a complete row of the tie. Bismillah. For scaffold enclosed with tarps or plastic sheets, a degreed structural engineer shall design the scaffold including tie spacing and configuration for the increased wind load. When we will put definitely such things, tarpaulins or plastics, increased wind load will be there. So definitely it will be then a special scaffold. A degree engineer will make the calculation, wind effect, and then will give the tie spacing and which type of ties we have to use, all these things. Okay. Next point we have clearance. So for the clearance, Base of scaffold shall be at least 1.5 times the depth of excavation away from the edge of excavation, unless adequate measures are taken to prevent the collapse of excavation and ensure the integrity of the scaffold foundation. For further, chapter 2.1 of scaffold excavations ensuring. Simply 1.5 into the depth of how much deep? 3 meters. So we will go 3 plus 1.5, 4.5 meters away. Two things are, we have to make sure the collapse of excavation under the load, and definitely once the excavation will collapse or settle, the side will be settled anyhow, the base plate will be displaced on the ground below the base plate is not stable, then what will be the stability of scaffold? So interrelated they are, but one thing, if they are protected against, maybe we have a strong shoring, maybe we have other means of uh, protection of that particular edge or support for the scaffold foundation. तो अगर इस तरह की कुछ सूरत हाल है, शोरिंग वगैरह इस तरह की हुई है जो लोड के स्काफोल्ड की स्ट्रेंथ उठा लेगी, एक्सपेक्टेड लोड उठा लेगी, then we will, or then we can go with that. Otherwise फिर हमें at least the 1.5 to the depth of scaffold gap रखना है. Scaffold shall not be erected, used, dismantled, altered, or moved such that they or any conductive material handled on them, for example, scaffold tube, conductive as electric conductor, might come closer to exposed and energized power lines than listed in table 2.2. So we will look at table 2.2. The minimum distance we have to maintain for scaffold, not only for scaffold, but for the material handled on the scaffold. For example, during erection, or maybe later on, if we do another work, we handle another metal, rebar, something on that scaffold. So what will be the expected length of that material, where up to maximum it can go? So from that point, that expected point to the power lines, we have to maintain distance according to table 2.2. मैंने एक स्टडी केस स्टडी एक देखा था somewhere in an English country, maybe, or maybe in US, I think it was. So scaffolding, definitely those people, they are scaffolding people, those they make it with care and this, that, maintaining the distance. But later on that scaffold, the group which was going to work, they are supposed to handle a pipe, a metal pipe. And as they were raising it, went a little bit up, the guy with the support of the guardrail, he pushed it down, means it becomes straight and horizontal, and it reached near to power line and they arced. So seriously electrocuted he was. So we have to look for that what material we are going to handle as well. Scaffold operation adjacent to overhead power lines are prohibited. Near to the power lines, they are prohibited unless one of the following condition is satisfied. What satisfaction is required? The power line has been de-energized, relocated, or protective covering installed to prevent contact with the lines. So normally local construction में भी आपने देखा होगा, हाउसिंग वगैरह में वो कवर इंसुलेशन 11,000 की जो नॉर्मली गली महलों में आगे पीछे लाइनें जा रही होती है, छोटी तो 4 उसकी होती है, कितनी होगी, 440 के लगभग हम कह सकते हैं, और जो 11 के भी या 11,000 की वो थोड़ी ज्यादा डेंजरस कंसिडर, डेफिनेटली दे आर मोर डेंजरस. तो उन पे कवरिंग शीटिंग जो है वो चढ़ा दी जाती है. स्टिल रिस्की, दैट कैन बी डन if it is de-energized. If the power line has been de-energized, positive means lockout takeout shall be used to prevent the lines from being de-energized, means from the source of the line lockout takeout have to be implemented. And then locally we ground those lines as well. For grounding again, technically we have to look forward. Line directly ground हो incoming line. बाजू का इस तरह होता है कि रिवर्स लाइन वगैरह वो नहीं, अगर इनकमिंग लाइन हैंगिंग है, ग्राउंड कांटेक्ट नहीं है, तो सिस्टम ट्रिप नहीं करते, और इस तरह के कई हादसा हुए हैं। अच्छा जी, एक पॉइंट और देखते हैं, फिर थोड़ी सी ब्रेक लेते हैं। मीन्स टू से द टेबल 2.2। ओके जी, व्हाट टेबल 2.2 says? Seems like complex, but two divisions are there. But the thing is that the protection for both is same. Protection for both is same, but they are written in two sections: the uh, shielded and unshielded. So let us consider that half the table we have to care about. Insulated lines. Insulated lines, our wires are cables. Those with the shielding, जिनके ऊपर ये अपना इंसुलेशन की शीट होगी या इंसुलेटेड होगी, जो less than 300 volt, normal those we have to maintain at least 1 meter distance of 3 foot. 300 volt to 50 kV. 50 kV means 50 plus 1000, 50,000. Minimum distance, at least distance 3 meter. What we call the 10 feet. If they are more than 50 kV, 3 meter, 10 feet at least, plus 10 mm for 0.4 inches. 0.4 inches कितना हो गया जी? 10 mm और 0.4, तो और तो इसको कितने में लाएंगे तो हमारे पास 10, 10, 20 और दो, तकरीबन 1 इंच के लिए हमारे पास 25 mm आ गया। वही 1 इंच के लिए 1 इंच बन जाएगा। फिर इंच का 40वां अगर लेते हैं तो वो यही 10 mm बनेगा फॉर ईच 1 kV। तो तकरीबन ये हमारे ख्याल 4 इंच बन जाएगा 1 फुट के लिए। इसी तरह जी मैथ वाले, अच्छा जी, 100 mm, 10 mm और 0.4 इंचेस। ठीक है जी, 0.4, और अगर 4, 4, 8, 2, 10, 25 mm हो गया 1 इंच के लिए, वो इंच बाई इंच हो गया, तो 1 kV के लिए 1 इंच डिस्टेंस। ठीक हो गया जी। किससे ऊपर? 50 kV से ऊपर। 50 kV से ऊपर जितने केवी हो गए, अगर 60 kV है तो उसको हम ले लें फिर 600 mm। 600 mm हो गया, और अगर दूसरे लफ्जों में कहें तो कितने इंच हो जाएगा? 25 के लिए 1 kV के लिए 1 इंच, तो 10 kV के लिए 10 इंच। ठीक है जी। क्लियर है या नहीं? गलत तो नहीं
ठीक
हमारी
है,
गल
ठीक
में? एटलीस्ट में ठीक जा रहे हैं।
है।
ठीक हो गया। ये पहले इसमें मेरा ख्याल है किसी वक्त इसकी कैलकुलेशन थोड़ी सी डिफरेंट थी। आ, उसमें यह था कि 100 mm में 4 इंचेस कुछ आ रही थी, अभी इन्होंने ये 0.4 किया, ये कुछ एक दो रिव्यू से। ठीक है जी। तो ये हमारी होगी 50 kV से ऊपर, आप कह लें 1 kV के लिए 1 इंच आप डिस्टेंस रख लेंगे। नहीं, 1 kV के लिए 1 इंच नहीं आएगा ना जी, तो इसको फिर देख लेते हैं। 1 kV के लिए 10 mm आएगा। 10 mm आएगा, और अगर 10 kV होंगे तो फिर हमारे पास 100 mm आ जाएगा। ये जी 1 kV के लिए 10 mm आएगा, 10 mm/kV। तो मीटर के लिए कितना हो जाएगा? कितने हो गया? 1000 हो गए। 1000 का कितना आ गया हमारे पास? 1000 इंटू, अगर मीटर्स करते हैं तो हमारे पास वही 1 मीटर आ गया। तो 10,000, 1 मीटर डिस्टेंस वही 3 फुट आ गया। 3 फुट डिस्टेंस के लिए हमें तकरीबन 100 kV के लगभग 3 फुट डिस्टेंस ऊपर जा रहे हैं, तो अच्छा खासा डिस्टेंस बन जाता है। तो 10 mm 1 kV के लिए ठीक हो गया जी। और 1000 mm का हमारा हो गया, मीटर हो गया। और ठीक है, फिर 1 मीटर में हम तकरीबन 1000 kV ऊपर जा सकते हैं। तो अगर 51,000 है तो फिर 1 मीटर नहीं, 10,000 होगा। 60 है तो हम 1 मीटर और बढ़ा लेंगे, यानी 4 मीटर डिस्टेंस हो जाएगा। 4 मीटर डिस्टेंस हो जाएगा 60 के लिए। अच्छा, इसमें भी यही है हमारे पास, अनइंसुलेटेड में भी हमारे पास यही है। अनइंसुलेटेड में भी चूंकि अनइंसुलेटेड में या नॉन इंसुलेटेड हमारे पास 300 से नीचे की नहीं होती, वो निकल गया हमारे पास। बाकी हमारे पास आ गया लेस देन 50 kV और मोर देन 50 kV, वही 3 मीटर और वही 3 मीटर प्लस 10 mm फॉर ईच 1 kV। ठीक है जी, तो ये हमारे पास कैलकुलेशन सेम आ गई। अब अल्टरनेट देखते हैं, अल्टरनेट कैलकुलेशंस क्या है हमारे पास। अल्टरनेट में हमारे पास है जी कि अगर ये पॉसिबिलिटी नहीं है तो यह हमें एग्जैक्टली वोल्टेज करना पता हो, फिर भी 2 times द लेंथ ऑफ लाइन इंसुलेटर बट नेवर लेस देन 3 मीटर। ये हमारे पास इंसुलेटेड की भी यही है और नॉन इंसुलेटेड की भी यही है। अब सवाल ये पैदा होता है कि ये क्या चीज है लाइन इंसुलेटर जी? है जी कोई इलेक्ट्रिकल वाले लाइन इंसुलेटर? तो लाइन इंसुलेटर हमारे पास ये चीज आ गई जी, ये हमारा लाइन इंसुलेटर होता है। मतलब लाइन हमारी जो आ रही है, पता नहीं कहाँ से आ रही है, ये आ रही है। ठीक है, अभी तस्वीर में कुछ अजीब सा लग रहा है। बहरहाल ये लाइन का डिस्टेंस रखने के लिए होता है, जो हमारी लाइन आ रही होती है डिस्टेंस रखने के लिए। तो इसकी जितनी लेंथ होगी उसका 2 टाइम्स, और इसकी लेंथ गिनी जा सकती है। अभी हमारे पास कितने हैं? 1, 2, 3, 4, 5। मेरे जहन में इस वक्त नहीं है, मेरा ख्याल है 3 इंच या इतनी इसकी एक की कोई लाइन होती है, लेंथ होती है लाइन इंसुलेटर की। जितने ये हैं जरबे उतने नंबर से आप कर लें तो इंचेस में हमारे पास डिस्टेंस आ जाता है। और मल्टीप्लाई बाय दैट, मल्टीप्लाई बाय 2। लेट अस से अगर ये 5 है हमारे पास और 3 इंच का है, तो हमारे पास आ गया कितना? 15,000/2, 30 इंच कम से कम हमारा ये डिस्टेंस हो गया। लेकिन वो बात वही है कि 30 इंच तो 2 मीटर से 3 मीटर से कम आ रहा है, तो एटलीस्ट 3 मीटर हमें रखना है। ये वोल्टेज पे डिपेंड करता है, जितनी वोल्टेज होती है उतनी इस इंसुलेटर की लेंथ ज्यादा होती है। तो इसकी स्टैंडर्ड लेंथ होती है हर पीस की, उस पीस के हिसाब से मल्टीप्लाई बाय 2 कर लेंगे उसकी लेंथ के हिसाब से। और उतना डिस्टेंस, बट दैट इज टू बी मोर देन 10 फीट। अगर मोर देन 10 फीट है तो उस डिस्टेंस के साथ जाएंगे, और अगर लेस देन 10 फीट है तो एटलीस्ट 10 फीट डिस्टेंस हम रखेंगे। ठीक है जी।
ठीक है सर।
ओके,
ठीक
एक
है सर।
शॉर्ट सी ब्रेक लेते हैं, और फिर हम जो है दोबारा वापस आते हैं इंशाल्लाह। फिर टाइमर सेट किया था। Bismillah. Okay, Bismillahirrahmanirrahim. Let us resume. So line insulator 6 inches है, just मैंने चेक किया, standard 6 inches इसकी होती है, अपना लेंथ होती है. So here in that case 6 into कितना है, 1 2 3 4 5, 30 इंच हो गया, 30 दूनी 60 इंच. Last foot. Okay. Am I audible to you?
Yes, sir. Yes.
Let us proceed further. We will try to complete it today, inshallah, this section to till our target, so we will not have any up down in the next one. The same one, and inshallah, we completed at least 2.6. Okay.
Okay.
2510 rising and lowering material using gin wheel. Gin wheels are to be fixed to scaffold for purpose of rising and lowering material during scaffold construction or use. Again, even when we are using it, we can use them as well. Shall be mounted on a cantilever tube projecting outward from the scaffold and shall be kept to a minimum distance not greater than 750 mm, 30 inches beyond the platform jo jayega. The horizontal tube holding the gin wheel shall be fixed with a right angle coupler to two scaffold posts. Again, two members. Posts are standard, whatever we can say, 39 figure, 139. Two types of gin wheels we can use, and maximum you can see from the center of the, normally the distance we take from the center of tube or coupler, wherever we are referring to the distance, to the next, to the center of the gin wheel, wherever it is tied or fixed. 750 mm or 30 inches. A ring type gin wheel is preferable. Ring type ये जो हमारे पास है, this one, because at the top it have a ring through which the tube is passed. If a hook type gin wheel is used, it shall not be hooked through a coupler. Most common observation है ये scaffold gin wheel की most common observation is this one, that people, what they do normally, they put a coupler, double or single coupler, and then they are hooked with that coupler. No, that's not allowed. We cannot put a coupler. If it is not ring type, it's a hook, we will not put a coupler. What we will do, it shall not be hooked through a coupler, but lashed to supporting tube with the hook, moused or moosed, whatever you can pronounce it. हुक के माउसिंग ये एक इंटरव्यू में बहुत पुरानी बात है. लैशिंग ने वो क्या बोलते हैं उसको जी, वो थ्रोट में जो होती है लैश, सेफ्टी लैच. The PMD question was, what if the safety latch is not there? Common answer होता है कि we don't allow. Okay, if it is supposed to be here, it is there, but we have sometime we have other solutions. We will mouse it. I say I don't know what it is, and so definitely वो इल्म समुंदर है, मतलब वो लाजमी नहीं होता हर चीज का, लेकिन ऐसी टेक्निकल चीजें स्पेसिफिकली सेफ्टी वालों के पास होनी चाहिए ताकि हमारी कंप्लायंस जो है वो एक परफेक्ट उसमें चलती रहे. तो जब हुक का थ्रोट होता है, अगर इफ इन केस समथिंग लाइक दैट, इफ दिस इज द हुक, वी हैव सेफ्टी लैश हियर. अगर ये सेफ्टी लैश नहीं है तो हम यहाँ, चूंकि ये थोड़ी सी एंगुलर होती है यहाँ से हुक, तो हम फिर इसमें फिगर 8 बना के ऐसे माउसिंग कर देते हैं. काफी सारे रिगिंग स्टैंडर्ड इसको एक्सेप्ट करते हैं ताकि जो भी बेल्ट वगैरह डालिए वो बाहर ना आए. अच्छा जी, तो हुक जो माउसिंग कर लेंगे एंड देन व्हाट वी विल डू. Okay, let me read the statement. But lash to the supporting tube with the hook mouse. This lashing will be through any type of. Sometimes we use rope. Sometimes we use the sling, 1 inch, 2 inch sling. Whatever, it should be proper. Sling again, we cannot put through the eye. Okay, you will wrap the sling, then the both eyes of the sling you will pass the hook. Otherwise, if we have the rope appropriate, rigging can confirm these type of things, the rigging department. But a load bearing rope, we can make a figure eight, then not complete, not during, कुछ इस तरह का होता है. फिगर एट हम बनाते रहते हैं रोप से, and then the rope we also make it tighter from here. So exactly a proper arrangement it becomes. In either case, the ring wheel fixed to the tube shall be prevented from slipping towards or away from the scaffold by one coupler mounted on either side of fixation. तो एक कपलर फ्रंट पे, एक बैक पे. डबल कपलर लगा सकते हैं आप, पुटलक लगा सकते हैं, सिंगल कपलर लगा सकते हैं, या चेक कपलर सिंपल हो वो लगा सकते हैं. तो पर्पस ये है कि ये इट शुड नॉट मूव हियर देयर. ओके, वन कपलर एट फ्रंट एंड वन एट द बैक in any case, either lashing or passing the ring through. Most important, should not be beyond 30. So नहीं तो आगे बंदे को ऐसे लीन आउट होना पड़ेगा. Okay, and what more? Okay, material to be raised shall be firmly attached to the gin wheel rope, and shall not exceed 50 kilogram or 110 lbs. 110 lbs या 50 ग्राम maximum, 50 किलोग्राम. Gin wheel rope shall be of the correct size to suit the gin wheel, usually 18 mm 3.4. अच्छा, एक और बड़ी सिरदर्दी होती है स्काफोल्डिंग वालों के लिए, जो बकेट होती है, स्काफोल्ड मटेरियल बकेट, वो डैमेज, जो कि उदाहरण इस्तेमाल करते रहते हैं, वो खराब हो जाती है. इट शुड नॉट बी डैमेज. माइनर उसमें अगर वो घिसा पिटा भी होता है तो वो उसके अंदर फिर जब कपलर वगैरह डाले फिर वो कंप्रोमाइज हो जाती है चीज. प्लैंक वगैरह जब होते हैं तो वो जने उसको हम फिगर की बेस पे उठा रहे होते हैं, उस केस में वो फिगर से स्लिप नहीं करते, डायरेक्टली रोप से स्लिप नहीं करते, बकेट वैसे नीचे एक्स्ट्रा प्रोटेक्शन में आ जाती है. और ये दूसरी एक ऑब्जर्वेशन है जो होती है. अच्छा, जेन व्हील के साथ एक और भी होता है. जेन व्हील मोस्टली मोस्टली तो नहीं, एक आध जगह ही मैंने देखा है, लेकिन वो लगी होती है हैंड रेल, गार्ड रेल के साथ. वहां भी नहीं हो सकती, बिकॉज गार्ड रेल्स आर फॉल प्रोटेक्शन इक्विपमेंट. दे आर नॉट लोड बेयरिंग और लोड होल्डिंग. शायद पहले भी हमने एक पॉइंट के साथ डिस्कस किया था. तो एक स्ट्रक्चर के साथ ओके यू कैन, और इफ इट्स स्काफोल्ड स्टिल यू कैन. स्ट्रक्चर फिर आप डबल कपलर वगैरह लगा के, कोई स्काफोल्ड ट्यूब लगा के स्ट्रक्चर के साथ भी, इफ द क्लाइंट अलाउज, मीन द एरिया ऑनर्स दे अलाउ. नॉर्मली 50 किलो लोड स्ट्रक्चर पीस के साथ इतना वो क्रिटिकल नहीं होता, बट स्टिल डिपेंड्स. ओके जी, यूजुअली 18 इंच की मनीला रोप, ये टाइप जो रोप होती है, ऐसे हम मनीला रोप ही अभी तो उन्होंने सिर्फ साइज ऑफ suitable to size of the gin wheel. अगेन अगर वो एटलीस्ट 18 mm नहीं हैंडल कर सकता जिन व्हील, तो फिर तो जाहिर है आप नहीं लगाएंगे. लेकिन इट्स अ रीजनेबल साइज टू हैव ए गुड ग्रिप. और उसमें मनीला रोप इज द बेस्ट वन. अदरवाइज जो लाइलॉन होती है वो भी क्रिटिकल है, वो स्लिप फैक्टर ज्यादा होता है उसमें. और इनकेस हल्का फुल्का वो हाथ से स्लिप करने लगे तो उसको अगर कोई ग्रिप करता है तो वो ज्यादा खतरनाक सी हो जाती है. और भी सिंथेटिक रोप्स कहीं आती है, लेकिन उनमें एक इशू ये भी होता है कि बस वो एलोंगेट होती है. इस ये अच्छी मार्केट की चीज है मनीला रोप, तो इसमें एलोंगेशन नहीं है, ग्रिप अच्छी होती है. डेफिनेटली द पर्सन विल यूज द ग्लव्स, बट स्टिल इट इज समथिंग प्रेफर्ड इन द इंडस्ट्री. हाँ, डैमेज वगैरह होती है, ये इसका काम लगा रहता है. edging factor, a lot of edging factor comes on that. High wind. Okay. High wind we have. Person shall not be on any scaffold or other temporary elevated work area during storm or high winds. Sustained wind more than 65 km per hour, 40 miles per hour, unless the scaffold or other elevated work area is indoor or otherwise unaffected by the weather condition. In that case, means plaster covered or something like that, or maybe in somewhere behind any building where the wind is not affecting directly. But again, उसका बाकी wind के factor तो होंगे. So, and when it change direction, that is another thing. Unaffected by the weather condition, outdoor scaffold or elevated work areas shall not be used during thunderstorm or when there is a likelihood of light rain. Definitely, we know that electricity is looking for shorter path. At elevation, more chances of being struck by light. Or again, person shall not be on a scaffold or other temporary elevated platform. It's not saying for erection. So keep in mind this 65 km per hour is a huge speed when it's come for the scaffold erection. So practically it's not possible. 65 here, that is for work on a platform, erected platform. Okay? Practically 60, 40, 45 km per hour erecting scaffold. आप 6 मीटर का आपने बोर्ड उठाया वो या 3 मीटर का भी एक गस पाए हवा का 40-45 किलोमीटर का भी तो you will not be able to hold that. तो ये वर्किंग है, इरेक्शन की नहीं है. Further tools. Only tools recommended by the scaffold manufacturer shall be used during scaffold erection and dismantling. Okay. Approved tools, whatever they will say. Okay. Definitely manufacturer, if they recommend, we have to use that one. Common tools हमारे पास क्या आ जाते हैं जी? बिस्मिल्लाह. Common tools हमारे पास आ जाते हैं spirit meter या level, spirit level, richer spanner, non-richer spanner. ये अपना टेप भी यूज की जाती है और थंब रूल पे भी काम होता है. थंब रूल पे भी काम होता है, but specially for special scaffolds, for loads greater than what we'll say 240, we have to be really precise. So then people have their own techniques. Sancha banate hain, what we call that. They will take the measurement at the bottom, then they will make one frame, one module, fixing the two couplers, then where it comes, they fix it, then loose, then they take it further at the height. So the thing remain in one dimension for transverse, longitudinal. But anyhow, different techniques are there. So what else we can have? The major component or the safety factor, the tool lanyard. Very critical thing it is, especially in live areas, because we are eliminating personal movement, but equipment pipes they are there. So serious outcomes can be there. टूल लैंडयार्ड बड़ी एक जरूरी चीज है. Commonly हमने देखा nylon rope, people they use that one at least, but it should be a proper tool lanyard, or if they are using that one, should not be compromised. So edging factor वगैरह damage वगैरह वो नहीं होनी चाहिए. Another thing we will look at the brass hammer. If the work is to be done in the live area, the hammer should be brass. Because if we strike metal to metal, that's a spark producing tool and hard work we have to have. And more than the hard work, what if we have any gas? Considering the classification of area, the nature of hazardous nature of the area, we have to decide whether we use the brass hammer or not. In live areas should be brass. Sometimes they also strike with the spanner. Okay, and seriously wrong attitude. Spanner will get damaged, definitely. And scaffold component will not be tightened enough. Okay, 2.6. Horizontal members. Every line of post standard shall have runner ledger installed horizontally in continual length along the entire scaffold length longitudinally, facade, and barrier transom installed in a continuous length horizontally across the entire scaffold width transversely at each lift. Means whenever there is a lift, complete the transom and the runner should be in both directions. Like here we can see, they are throughout the length. Maybe another post, it is supposed to be there. Okay, complete set. Okay, this. No lift height shall exceed 2 meters 6.5 feet. So this is what we are referring to from the center of this tube to the next tube center. This center can be less, but will not be more than 2.6 feet, 2 meter or 6.5 feet. Whatever the choice is yours. And the foot or a meter cannot exceed 2 meters. Board barrier intermediate transom shall be installed as required to limit plank span of the distance specified in 2.256. We already have looked at that as figure 2.2, and where necessary to accommodate a difference in the plank length. These may be removed when no longer required to support any plank. Means when we are using any lift as plank level, we will put these intermediate transoms to support our boards to minimize the span. Or if we are having different size planks, again we have to give the support beneath them. As we says, should not be more than 12 inches and less than 6 inches beyond the runner and beyond the barrier or board barrier. And technically, otherwise, same thing they are. And yes, once we remove those planks, they are no more required. The transom will be there, or the barrier, the one which is with the post. The one in between the bay we put, we can remove that one. Pictures like we have seen before. Now this is again intermediate transom or the board barrier. That's the barrier or transom. The one which is with the post. The one which is with the post. So once we are not in requirement of these planks, we will remove them. At the same time, we can remove this board as well. Okay, barrier transom and board barrier intermediate transom shall be installed on top of and not underneath supporting a runner. Okay. The figure is the same 40 we are using. I think the reference they have just something clerical mistake we will say. ये एक और identity भी होती है. We've talked about this little bit before that. How we will know longitudinal side? Longitudinal side we have runner. For example, हमारी बर्ड के स्काफोल्ड है, तीन एलिमेंट्स हैं ट्रांसफर्स longitudinal में. So the runner is the one which will tell us, and where the runner will be down, transom will be up. ट्रांसम ऊपर होगा या बोर्ड बैरियर, और रनर या हमारा जो लेजर है वो डाउन होगा, नीचे होगा. ठीक है जी. बट दे विल रिमेन इनसाइड द पोस्ट इवन एट द एंड. ये भी हमारा इनसाइड द पोस्ट है, ये भी हमारा इनसाइड द पोस्ट है. वी कैन इंस्टॉल ब्रेसेस इनसाइड, but at the same time we can install braces outside. Other all members will remain inside post. Bridging, okay, the gap between of scaffold shall be as conceptually shown in figure 241. Conceptually means, again, in such situation, mostly we expect that scaffold is special, that there will be design and so on. But anyhow, typical normal gap, if we have to give typical bridge for 2-bay light duty scaffold, okay. So normal situation, if we have to give, you can see here we are having some additional braces. तो ये brace हमारी diagonal इसको pull कर रही है, ये इसको pull कर रही है, and we have a load bearing here. Okay? So we can have a 2-bay, maximum 2-bay. So here typical bridge for 2-bay medium duty scaffold. Then we have to put a ledger. I think we can use them in this sense. We can use them even they are not special scaffolds. So ये हमारा simple transom आ गया. Or in addition, we have a 2 bays covered by a ladder beam. Normally we refer to ladder beam. Again, a typical bridge 2-bay example. Okay. In certain cases, check couplers and double couple standards may be required. Okay. We know that when load bearing we are going to do, we can have additional components. Check coupler, the slip, for the slip factor, we know, and additional we put there. Okay, we'll talk about it later on again, inshallah. So also a type of beam, we can say, what they say is unit beam and beam ladder. So this is how we can make the bridging. Scaffold trusses, ladder beams, and unit beam, etc., shall be horizontally braced. Okay. For example, by bridging braces, horizontal brace, vertical, these are the horizontal, vertical. In addition, horizontal braces in the plane, so they will not move the things here, there. Ladder beam or trusses, these type of things. Okay. What it means to say कि देखिए ये अब double side है ना, 2 pipe है इसके ऊपर नीचे. So this one is coupled from here, and this one, although we couple, but still we want a plain brace. So इसकी जो literal movement है ना, वो किसी तरह ना हो. ठीक है, तो ये चीज हम कंट्रोल करने के लिए इसको horizontal plane पे भी ब्रेस देंगे. Okay. We must shell by bridging braces at the top and bottom chords as specified the manufacturer to prevent little torsional buckling. Little buckling or torsional buckling rest as the quarter point. Okay. So again, as per manufacturer होगा, जो बीम लेडर बीम का मैन्युफैक्चर है उस हिसाब से, अगर सिस्टम्स का फोल्ड है तो जो डिजाइन वो दे रहे हैं उस हिसाब से. वर्टिकल ब्रेसिंग, to prevent excessive sway in both the transverse and longitudinal direction of system, and tube and coupler scaffold for the full height of the scaffold shall be installed at a angle of between 35 degree to 55 degree above the horizontal. Okay, 2.27 and 2.8 for the, we will look at them inshallah tomorrow, 2.7 and 2.8, or maybe they will come under discussion. I think tomorrow we are going to look at them. Anyhow, transverse sectional brace shall be connected to either a post standard or runner ledger as close as possible to the intersection node point of the barrier transom and post standard, not more than 300 mm 12 inches from the node point, figure 42. So first we look at, okay, this is what we are calling about the degree. From wherever you will take. Now, this is what we are referring the degree, between 35 to 45 degree. Okay. So in this case, when we use here, I mean, almost 45 degree, they are coming. But it can be Maybe we have one here, maybe we have another one here. So degrees can be, but 35 to 55, least and maximum. Second is this said either transverse or longitudinal transverse, okay, sectional also we refer to sectional brace, shall be connected to either post or standard or runner ledger. So considering it the transverse side, we will put this either with this post or with this transom. Okay, ledger. The transom side it is coming, okay, from the width side. So, but near to the node point where these ledger and there's ledger and this standard they are becoming in contact. This is what we say is node point. Here we have a double coupler, post is attached with the runner. Brace is to be near to it, but within 12 inches. Now we can see here in the picture, this is the center. From this center to this brace, 12 inches maximum center of this coupler or tube, we will say. Less than it can be, but should not be more. Again, the top one will be within 12 inches. Okay, should not be more or less than that. Less than that, okay, acceptable, should not be more than that. Next point we have longitudinal facade braces shall be connected to post standard as close as possible to the intersection node point of runner ledger. And now we are talking about the facade brace. And not less than 300 mm 12 inches from the node point. Again, the same node point definition and same thing we are talking about. Okay, we have flipped the picture. So 30 to 35 degree. And here the post and standard because they are at the front. So post to post we are going with them. Okay, because post is outer, we are attached them with the outer side. It's technically with normal couplers we cannot fix them with the ledger. So, but it will be closer to this point. Again, the same thing within 12 inches from this node point. Okay. Like here it is almost 45 and it remains in the same direction because we have 90 degree. It's not 90, but exactly 90 degree we are going. So every set. Braces end may be joined together with end-to-end sleeve couplers, not joint pins. Alternative for bracing adjacent to large tension loads. Okay. Alternatively, for bracing adjacent to large tension load, bracing end shall be overlapped by at least 300 mm 12 inches and joined with at least two adjacent swivel couplers 244. So 244 shows us if we have taller scaffold, big scaffolds, where the load, wind load, all these type of load expectation is more. So then we prefer instead of end-to-end coupler, we prefer overlapping. 12 inches, one over the other, and then we 90 degree coupler cannot be used definitely. Swivel coupler we use for this parallel joint. Between two joints, at least 100 mm, 4 inches at least. Between two joints, 4, and again from center of this, if we will make here almost it will come almost 100, but not 100 definitely. We can put little bit more. We can make it completely from the center to outward 4 inches. So 4 from here to here, 4 here to here, 4, 1 foot. At least 1 foot. Can be little bit more. Can be little bit more. 12 inches or 300 mm or 1 foot. Okay, system scaffold, only specific manufacturer and brands for system scaffold are permitted to be used within Saudi Aramco. Contact the area loss Saudi Aramco loss prevention division, LPD, what they call now loss prevention, for details. Okay, no other manufacturer or brands of system scaffold may be used. System scaffold shall be designed and constructed in full compliance with the system scaffold manufacturers information, grid size table. Grid size table, like sometimes we bring some table chair, something like that, any cupboard like these things, a specific diagram comes. Okay? How much the distance will be, vertical, height. So these type of things, specific measurements at least to be achieved from the manufacturer for proper use of their system scaffold within Saudi Aramco. So still, if it is up to a mark, up to a standard, by after obtaining approval, other scaffolds can be used. System scaffold from different manufacturers shall not be intermixed unless permitted and written by each manufacturer whose system will be intermixed. In that case, both have to be agreed that our system can be used with that one and that vice versa. Also, tube and coupler scaffolding shall not be intermixed with system scaffold except bracing and as noted below. Bracing they allow, ladder support also we use, drop bar also we use. Unless otherwise specified in the system scaffold manufacturer instructions, all outdoor system scaffold shall be vertically braced in both direction with diagonal. Diagonal, this is 90-degree, and other than 90 is diagonal. With diagonal bracing between 35-degree and 55-degree. The same requirement for the tube coupler scaffold are generally for every scaffold that within 35 to 55-degree, the braces will be either the diagonal braces, either they are transverse or longitudinal to its full height for each 10 meter 33 feet. So it means every 10 meter 33 feet, we will put another brace. Then we go further, then we put another brace. Okay? So this is what we are going to do with system bracing. Okay, our co-host was out for a moment from the meeting. Anyhow, coming back, so diagonal, the system scaffold from bottom to top, every 10th meter we have to go with the full height bracing. Bracing for system scaffold shall be specifically designed for the grid size of the scaffold, the bay length, or even the transverse width of the scaffold. However, where specifically designed system bracing cannot be used, tube and coupler scaffold components may be used as bracing for system scaffold. This is the reason you can see here, like a cup log. So a T transom seems here, but anyhow, our bracing is fixed. So this bracing we cannot fix other than this point. So they are with a particular length. So from one bay to bay with system scaffold designed they are. So if we cannot, then we go with the tube and coupler bracing, that is acceptable. As I said, ladder support, drop bars, we use also. Similarly, to hold the tag, in some cases we also use because tag have to be through a permanent member of scaffold, then again we use the system scaffold. Hopefully we can go for 5 minutes approximately to cover this 2.75, or we can keep it for tomorrow. Okay, we'll not go in fast. We will keep it for tomorrow, inshallah. Almost
Okay,
it's
sir.
10 o'clock. So everything have capacity. I appreciate your efforts, but it's really difficult, especially when we have DMD and then we are going for something. Before closing, let me know if you have any suggestion, any question.
I don't have
No,
any
sir.
question.
Okay, anyone else? Okay, in that case,
No, sir.
okay. So in that case, thank you for your time And again, inshallah, tomorrow at the same time, we will start our 8th day from CSM section 2.7 onward, inshallah. Thank you,
sir.
everyone. Have a nice time. Thank you. Assalamu
Thank you,
alaikum.
sir.
You're welcome.